Hello, everyone. So what is Arinc 825? Arinc 825 is an avionics communication standard published under the umbrella of the Aeronautical Radio Airlines Electronic Engineering Committee. It defines how the automotive-style controller area network bus is to be used for airborne systems. In essence, take CAN bus and adapt it for the rigors of aircraft or avionics use, timing, determinism, error handling, environmental/maintenance considerations. It aims to serve as either a secondary ancillary network in large commercial aircraft or even as a primary network in general aviation. Key specifications. Physical or protocol layer. Arinc 825 builds on the CAN protocol and uses the CAN physical data link layers with aviation-specific constraints. It uses the extended frame format 29-bit identifiers rather than the standard 11-bit CAN identifiers to allow for more nodes or subsystems in better addressing in the aviation environment. Data rates, traditionally up to 1 Mbps, though later evolution is being integrated or referenced. Topology bus typically with termination resistors, as in standard CAN. Message traffic Arinc 825 defines minor time to ensure determinism. For example, the idea of bounding the number of messages a node can send within a minor time frame, limiting bus utilization to ensure predictable latency. Time resolution is less than 1 microsecond error detection. Fault tolerance. Avionics-grade constraints. Arinc 825 has enhanced error handling compared to generic CAN usage fault confinement, node isolation, redundancy provisions. In avionics setting, there are requirements for environmental robustness, like temperature vibration, EMI. Though the specification itself references that implementers need to comply with regulatory certification bodies, Federal Aviation Administration, European Union Aviation, Safety Agency, interoperability, standardization aspects. The goal is to standardize how CAN is used in airborne, in systems message formats, bus scheduling, network management, bridging to other avionics buses, device interoperability. It's a voluntary standard, i.e., one selects to implement it, and must be used in compliance with the applicable certification regulatory norms, where Arinc 825 is used. Sensor actuator networking for linking sensors, actuators, auxiliary systems on aircraft, general aviation aircraft, UAVs, autonomous aircraft, prototyping, test and simulation, benefits, and why. Use Arinc 825, reduced wiring, weight standardization, interoperability, deterministic behavior, fault tolerance and avionics-grade robustness, limitations, bandwidth. Although CAN is fairly high speed for many subsystems, it is not as high as full Ethernet or AFDX backbones. So for very high data throughput, other buses may be needed. Implementation must meet avionics safety or regulatory requirements. It's not just about the bus standard, but also how it's implemented. Although Arinc 825 standardizes CAN, usage integration with other avionics buses, gateways, scheduling of many nodes, still demands architectural diligence. The standard has evolved. Implementers must ensure compliance with the correct version of Arinc 825.
Then, let's head to the next topic, which is Arinc 826. Now, what is Arinc 826? The standard title is Software Data Loader using CAN interface, like a protocol for software or firmware, like line replaceable modules and line replaceable units over a CAN bus interface. It is meant as an alternative to the higher-end software loading standards, such as Arinc 615A or Arinc 6113. Defines the software loading operations in terms of sequences of CAN messages, the byte organization of those messages, the transport layer, and the CAN bus implementation for the loading function. It is not intended to specify how the target device manages its non-volatile memory erase or upload or rollback logic. Memory management is considered platform-specific and outside the spec. Key specifications, features. Here are the main technical aspects of Arinc 826. 1. Application layer. Defines operations such as target selection abort sequences, configuration parameters, and the software loading operations themselves defines the message definitions for software loading and the byte structures of messages. 2. Transport. CAN bus implementation specifies how the CAN bus is used for software loading. Message identifiers, segmentation of large software blocks into CAN payloads, since CAN messages have limited payload size and sequencing, checks, etc. 3. Relationship to CAN and other Arinc standards. The underlying physical data link is the CAN bus. Arinc 826 builds on that interface for the data loading function. It is complementary to other CAN-based avionics protocols, such as Arinc 825, which is more about CAN for airborne network communications in general, and others like Arinc 810, 812 for galley systems. For example, the press release by Vector Informatics states Arinc 826 specifies software data load over CAN. The mechanisms of Arinc 615A were adapted and optimized for CAN here. 4. Document structure. Scope. From the table of contents of the standard, which is introduction, purpose, scope, definitions, application layer, which are target selection, abort sequences, configuration, parameters. Software loading operations. Message definitions. CAN bus implementation of Arinc 826. Common CAN bus requirements. Transport. Layer configuration parameters 5. Performance and use case notes. Because software loading often involves large blocks of data and possibly slower or error-prone mediums, the protocol has to manage segmentation, retries, integrity checks. It is used only during loading upload to some phases, not normal real-time operational traffic. Some sources say no usage during normal operation. Applications and typical use cases there, they are used for LRU, LRM, software updates on aircraft. For subsystems which support software firmware updates, loadable software parts over the aircraft network, Arinc 826 provides a standard protocol to load the software onto the unit via a CAN bus interface. CAN-based avionics subsystems. Many modern aircraft use CAN buses for subsystems like sensors, actuators, secondary systems. If such a subsystem is software loadable and uses a CAN interface, Arinc 826 is applicable. Then, simpler networks where Ethernet is not used. Instead of using Ethernet-based software loading, which may be more complex or expensive, Arinc 826 offers a CAN-based alternative for simpler devices. Test and maintenance and ground support. In ground maintenance, software loading to LRUs can be achieved via the CAN bus using Arinc 826 as the protocol. Tools from Vector Support, Arinc 826 for simulation testing. Benefits and why adopt Arinc 826 standardization. Having a standard protocol for software loading over CAN means that multiple vendors/suppliers can interoperate, rather than each having proprietary loader formats. Leverages CAN infrastructure. Many avionics subsystems already use CAN buses. Arinc 826 enables reuse of that physical medium for software updates rather than introducing a separate loading network. Lightweight and efficient. For lower bandwidth/less complex subsystems, a CAN-based loader is more lightweight than full Ethernet loading cost-weight savings by avoiding heavy Ethernet or separate wiring solely for loading. The aircraft system may save weight/cost. Maintenance support. The standard supports the life cycle aspect of avionics, updating software, in field, ground, or depot environments. Considerations and limitations. Because KAN buses have limited payload size, loading large software images will take longer than high-speed networks. Arinc 826 is specifically for software data loading, not for normal operational data communications. For high-speed real-time avionics network traffic, one still uses other standards. The target LRU/LRM must support the loader protocol and memory management for download-upload. In aviation, any loading protocol must be assessed for safety, integrity, traceability, etc. Since it is a standard only for software loading, additional system architecture